Welcome, everyone. My name is Sean Conley. I'm the State Soybean and Small Grain Specialist at the University of Wisconsin-Madison. Today, I want to kind of go through and address some of the questions we've been getting related to rethinking soybean planting dates. And I want to frame this as part of a collaborative work that a group of my scientists and I have put together known as Science for Success. So today, we'll talk a little bit about our conglomeration of Science for Success scientists across the state, across the country, and then also get into rethinking, some thoughts related to soybean planting date. Now, whenever I give a presentation, I always like to thank my co-authors. There's too many here to list, but I just like to thank all of you that are related. You'll see many of them here in the next slide when we talk about Science for Success. But I always like to thank the Wisconsin Soybean Marketing Board and the checkoff program across the country. I always like to tell people that roughly 80% of my funding on a given annual basis is checkoff funded through farmers across not just Wisconsin, but the North Central region, as well as the entire United States. So with that, I'll kind of get started and talk about our group called Science for Success. This is a group of scientists that our communication efforts are funded by the Wisconsin, the North Central, and more specifically, the United Soybean Checkoff Board. And what it is, basically, it's over 22 of land-grant institutions shown here on this figure across the United States. And it's in addition to our state soybean board. So for me in Wisconsin, it's also a collaboration with the Wisconsin Soybean Marketing Board, but also the United Soybean Board. So what this allows us then to do is a collective group is come forward with local problems that we're seeing within our states, but address this at a national level and then be able to deliver unified information to all the soybean growers across the United States. Now, here's just a good image of this motley crew, if you will, of scientists that are part of our Science for Success team. And one of the great things about this is we were able to leverage not just our local checkoff programs, for example, Wisconsin, the North Central, or the other regional checkoff programs across the United States, the United Soybean Board, but also federal programs such as NIFA, FFAR, and other USDA grants. So it's a really good way for us to take the checkoff dollars that you are all supporting our local efforts with and expanding those and across not just our individual states, but across the country. And the first thing that really led us into this collaborative effort would be a coordinated research project. So many of us have these specific problems that aren't just specific to our individual state, but they're specific to either regions or the entire country. And what we're trying to do is try to get as much information that affects our local growers, but also how these challenges affect growers across the United States. So it allows us then to develop a coordinated research all across the country. The other good thing it does is allow us to leverage our local knowledge. For example, in today's presentation, I'll be focusing a lot about planting date. And obviously, planting date is important, not just in Wisconsin, but it's also important from North Dakota all the way down to southern Louisiana. But that local knowledge of how that influence and how our recommendations influence farmers in those specific states is critical, that we have this collaborative knowledge and this coordinated research to make sure that we deliver that information that best fits the growers in our individual states. And lastly, it's about amplifying information. By able to coordinate our research, leverage our local knowledge, and develop unified messaging boards, if you will, we're able to amplify our information and get that out to not just our growers, but also the regulatory bodies within our states, regionally and nationally. So it's a great opportunity for us to take the information that's funded by the checkoff across the country and amplify that information. We'll show another really good example about that in a few slides, talking about how we were able to influence our AMS replant dates for soybean. One of the first projects we worked together was a question related to prophylactic applications of micronutrients. So this is probably one of our very first collaborative we did. And this was actually probably born before we actually had our Science for Success team together. And one of the good things about this work is we're able, again, be able to deliver information from multiple site years and to identify, are there regional differences, state differences, or national differences related to how or when these prophylactic applications of micronutrients should be applied to soybean. So this was an example of all the locations that we ran in both 2019 and 2020 across the United States. And interestingly enough, which we received a little bit of feedback from, I shouldn't say a little bit, a lot of feedback was, is that we didn't really see any significant response in terms of yield response that would be profitable to a prophylactic application of a micronutrients applied in the reproductive growth stage of soybeans. Now, this kind of pushes back a little bit about some of the recommendations out there, but I think the key point about this is one thing is we have a collaborative research. We're looking at many different environments, many different regionalities across the United States, and we see a very clear message to farmers. Specifically, if we're going into a growing season like 2025, where we're going to see basically going to be really tight margins, this might be one of those products that farmers, if they don't typically see a response because they don't have a micronutrient deficiency, then they may want to remove from their spray program. So it's a good example of being able to collectively work together to come up with a solution for our United States soybean growers. And in fact, by removing this prophylactic application, we're saving growers as much as $13 an acre. So that's a huge amount of savings for those farmers. So again, just an example of many that we're doing to be able to deliver our information to farmers with a unified message for the U.S. soybean growers. One of the other projects we really work on is delivering extension information. So we might not have specific research related to this, but this is a project where we looked at high-speed planting. It's a project led out of the state of Louisiana. We're looking at how can we utilize some of our new technologies, i.e. planter technologies, such as high-speed planting, and what are the best management recommendations for farmers. We've been able to deliver a unified messaging and information related to that, and other information. So I guess the point of these few slides were just to familiarize the audience here with Science for Success when you see our logo, and really kind of help us amplify our messaging moving forward. So for the remainder of this presentation, I want to really talk about some of the work that we've done collectively as Science for Success and individually as PIs across the country, looking at the influence of planting dates in soybean production systems. Now, I think this is a kind of a paper that we had published now. It's almost a decade old, but I think it brings up a reflection of what we're seeing across the United States. Now, I don't generally talk about climate change when I have these discussions directly with farmers, mainly because the term climate change is highly politicized. That is either a red or a blue phrasing, so it really is difficult when you bring up a term, this is calling it climate change, people's minds go a certain way. However, I think most farmers would recognize that we have seen a lot of climate variability over the last 10 to 20 years. And some of the work that we've seen and being able to pull out is that we've seen that across the United States. For example, we've seen the influence of some of the climate variability that we've seen over the last 20 years actually have a positive influence in Wisconsin, where we've seen the relative yield gain on a per annual basis at a quarter bushel per acre per yield. However, we get to other states, let's just use Ohio for an example, they're actually losing 0.3 bushels per acre per year due to this weather variability. And a lot of that has to do with precipitation timing and heat. In terms of monetary values, that gets us in Wisconsin at basically $770 million that has been for profit that have gone into farmers' pockets. But you move up to Minnesota, that's $1.7 billion over the last 20 years. So again, there are some areas where some of the climate variability has been good for farmers, and then states like Iowa and Ohio, where we're pushing 2.5 to almost a negative $3 billion yield loss associated with it. So the point here is we're really trying to utilize our information, understand the challenges that we have with a variable climate across the north central region, and for that matter, the United States, and deliver best management practices. And we want to target that specifically talking about planting date. And one of the cool things we've been able to do is it's kind of interesting. I've been at the University of Wisconsin-Madison now for like 17 years. About 8 years ago, I redrew our maturity group map. We see here in southern Wisconsin, basically right across where I'm speaking to you all from right now, our maturity group map suggests that the Optimal maturity group for yield would be a 2.5 maturity group bean. If I'd go back and look at what that recommendation was 20 years ago, that maturity group bean would have been a 1.5 maturity group bean. So we have seen some differences in how that climate and maturity groups have changed, not just here in Wisconsin, but across the United States. Now, to capture some of these questions related to soybean planting date, we are fortunate to get funding through the North Central Soybean Research Program. So the North Central Soybean Research Program is a program where for the states in the North Central region, each individual state allots state checkoff dollars into a larger pool to ask and answer larger questions. So what we were able to do is the first idea of this project was this boots in the ground project where we successfully went and collected survey data, yield data, all of the agronomic information, all the soils data, all the weather data for over 8,000 farm fields and over 600,000 acres of data. And each one of these red dots you see is from a farm where we collected that data from. So it's probably the biggest amount of public information related to soybean management and production systems. From this, we were able to ask and answer a lot of very cool questions. And one of the things is, when we're looking from the perspective, what's actually driving soybean yield, and how we've got some really cool answers to this. Now, how you would read this figure is as you move up the figure and to the right, these are the factors that are most predictive of soybean yield. And if you see sowing date, i.e. planting date, is the one, if not the most predictive, highest predictor of soybean yield. So it's really clear to understanding that from these farm fields that that's what's driving yield, is how soon farmers can get into these fields. And if we look at how and where this distribution is, we were able to utilize this technique called implementing a technology extrapolation domain. Now, this is a technique developed at the University of Nebraska-Lincoln, where basically you pool water holding capacity, productivity, yield potential, environment into a larger bucket, if you will, and you assign that as a specific TED. From that, we lay that over the geography. We can develop somewhat precision recommendations to farmers and how you would interpret this figure right here. And I will just go right here in the middle of the stake. It's easy to see this TED 4R, which is this orangish yellowish coloration. We move to the right, we look at TED 4R. And what it shows us is roughly after about April 15th, farmers in that area, which is basically 421 farmers, have reported their data to us, and we see a yield loss of 2.1 bushels per acre per week by delaying planting past that April 15th date. It's a really good estimate of using farmer-driven data to allow us to inform our models to let us know what this influence of planting date is. So it's very huge. We see anywhere from a range of negative 1.4 bushels per acre per week, all the way up to North Dakota, where we see almost a 3 bushel per acre per week in this TED 3R. So it's really good information, again, driven directly from farmer information that was delivered to us within the Science for Success North Central model here. Now, obviously, we understand that planting date sets us up for success, but there are some influencers that doesn't always predicate that we are going to get that success from early planting. And one of those would be our water balance, i.e. precipitation values during that pod set or that seed set period. And I think this is a really good example that shows us here that I'll go back to this TED 3R, which is North Dakota, and we'd be able to model some of this by looking at some of the phenology data and the weather data that we were collecting from farmers that show that if we have a negative 3-inch water balance, i.e. we're short 3 inches of rainfall during that seed fill period, we will not capture that 2.8 bushel per acre per week yield gain by planting early. So obviously there's an environmental driver or influencer that's involved with this. But I think what this really allows us to do, though, is have farmers look at where their farm lies in relationship to these TEDs, and it kind of helps them understand in their specific region or zone what this influence of planting date is. Now, one of the things we always see with planting day, we get a little pushback from both agronomists, seed individuals within the industry, is this influence of obviously there's some risk associated with early planting. A lot of that risk has to do with reduced stands. And one of the great things we've been able to, again, utilize from this collective team of scientists across the United States, known as our Science for Success team, is we're able to take not just existing data, but past data as well in order to kind of work together as a group and come up with some of these recommendations. A good one would be seeding rate in this case and how that influences with early planting. And what this shows us right here is what that influence of a reduced stand has on our average yield level. So I'll just use Wisconsin for an example because that's where I'm an agronomist. And what I tell farmers in Wisconsin is you go out and you basically buy a bag an acre for soybean seed. In this case, most of the seed industry in Wisconsin sells it at 140,000 seed count per unit. So that's where I tell farmers buy a unit of seed, which is 140,000 seed count. You take that seed number, and in low yielding environments, you increase your seeding rate. So you put it about 160,000 seeds. In those high yielding environments where you have white mold challenges, or extreme or lodging issues, you drop that seeding rate down to about 100 and 110,000. The other key thing is understanding that we're going into these early planting situations and we may have a reduction in soybean stand, is that we can lose roughly half of our stand in soybean in these early planted situations and still get 99% of our yield, okay? And even if we lose almost 2/3 of our stand from that early planting situation, remember we're dropping 140,000 seeds per acre, but we get an effective stand of 50,000 actually plants out there. We're still at 95% yield potential. So that's really a key point here, is understanding how this planting date interacts with all the other different management practices we employ in a given growing season. And we'll kind of talk a little bit more there during the rest of this presentation. Well, I kind of want to redress this whole thing, and I kind of mentioned it earlier about how this team of scientists can help you as a farmer and community. About 2 years ago, the RMA, the Risk Management Agency, approached our Science for Success scientists across the United States and asked, would you help us redraw our replant coverage maps for our RMA crop insurance? So we were very fortunate that we were able to have that data and be able to take that information and utilize it to help farmers really redraw these maps. And I'll speak specifically to Wisconsin because that's my home state. If you look at the state of Wisconsin here, right now we have 3 different planting dates. Okay, this lower part of the state, the bottom third, would be April 15th. Probably the middle section, middle to middle north, would be April 20th, and the north would be April 30th. All right. So prior to this change by RMA, our entire state would have been April 26th. We've made some pretty significant changes in moving this back anywhere from roughly 5 to 10 days. What does that mean to farmers? So in 2024, I kind of did a back of the envelope conservative estimate based on the number of days we can go out and actually have machinery operations accrue according to NASS data. I mean, how many days can you work out in the field? Roughly how many days we can plant by planting progress. And I saw just in 1 year alone that this change in RMA, going back anywhere from 9 to 5 days, depending on where you are in the state, provided roughly a very conservative number of $5 million of profit going into farmers' pockets, and then obviously going then into the local community. So that's just 1 year in a state such as Wisconsin, which roughly has 2.2 million acres in a given year. Now you pick a state like Iowa, Illinois, where we're pushing 10 million acres, you're probably talking anywhere from $10 to $20 million of added revenue by this change helped by the Science for Success team. So the point I really want to make here is there's a really good group, and hopefully we're making effective change for farmers, not just in our immediate states, but part of our direction is be able to make this change at the national level. Okay. Now, we had talked a little bit earlier about planting dates, and one of the things with how this interacts with maturity groups is we've seen this change. So one of the things we're really looking at, and we have farmers really pushing these earlier planting dates and wondering what should they do in terms of managing or changing their maturity groups. We did this experiment, and this is just Wisconsin-centric data, so we'll kind of focus on us. We went through and we planted anywhere from a 0.3 maturity group bean all the way up to a 2.9 maturity group bean. This is probably a better example if you see this picture here. This is a drone imagery taking on September 14th of 2023. If you look to our left here, we will see the planting date of April 12th, April 28th, all the way up to July 20th. July 20th is typically when we see winter wheat come out and harvested. And now we have basically double crop insurance, which was part of this RMA chain. So it's another point where our Science for Success team was able to help deliver data to the RMA to be able to help make these changes. But I always like showing this picture here because if you look to your farther left, this 4/12 date, and this was taken again on September 14th, this first plot in the bottom left here would be a 0.2 maturity group bean. We can kind of go back and forth across here. On this right-hand side here, lower right, this would be a 2.9 maturity group bean. And this picture was taken on September 14th. Why do I keep repeating that? Because 2 weeks later, it's a picture of that same field. And it's just always amazing to me about the phenology of how soybean changes based on remembering that soybean is driven by both heat and light. And this is that exact same plot that was bright green 2 weeks ago. And we're probably we're probably 10 days away from harvesting. So this allows us then to be able to take this information and understand, yeah, farmers in a plant early, they want to get out there in April. What is the optimal maturity group being that they should be planting in that situation? Now, we look at some of this actually data. I'll take a minute and describe this figure for everyone. How you would interpret this figure is on the left is the maturity group we planted. Remember, we started roughly at about a 0.2 maturity group bean. We went all the way up to a 2.9. Okay. On the bottom is our planting date. So in 2022, we couldn't get in very early. We could only get in about May 9th. We had some challenges with some harvest-related issues. We could only harvest up to our June 30th. So this is our planting date. And then on the z-axis, if you will, we have our yield. If you look at this figure, what this tells us is that farmers planting before May 19th, you can plant anywhere roughly from a 1.5 maturity group bean all the way to a 2.9 maturity group bean and have roughly the same yield. All right. Now let's fast forward down to 2023. In 2023, we were again able to get in and plant on April 12th. We were then planted all the way through our July 20th, but we see from May 16th and earlier, anything from a 1.0 maturity group bean and earlier yielded in that 80 bushel yield range. So what does that tell us? Okay, how does this help inform farmers? So what this tells us is that there are high yielding genetics across a wide range of maturity groups that farmers can implement on their farm. And why is this important in terms of this whole planting date related issue that we're talking about? The farmers can get in, plant an early maturity group bean as early as possible and has a very similar yield to what we would have seen as a later maturity group bean at that same time. It allows that farmer to get out there and start combining that soybean out early. In this case, we're probably taking anywhere from 10 to 2 weeks earlier. Okay. And for us in Wisconsin and for the northern climate, getting our beans out early is super important for two critical things. The first thing that's really important for us to handle is getting our winter wheat established after soybean. In Wisconsin, our cropping system, optimal cropping system, would be corn, soybean, followed by winter wheat. That's the rotational sequence that we should use. In Wisconsin, we tend to start seeing winter wheat yield loss roughly about September 20th. We lose a bushel per acre per day. So traditionally, if we're planting a late maturity group bean and we're not getting that soybean crop harvested until after roughly October 10th, when we should have been planting on September 20th, we've lost 20 bushels of winter wheat yield. Okay, which in Wisconsin, that number is 100 bushels per acre. If a farmer can't make 100 bushels per acre, they're not going to grow wheat. So this is a good way for farmers to plant a soybean, get maximum yield, follow it with winter wheat, and be able to get over 100 bushels to make that profitability. The other key point is those farmers that don't have dairy in the rotation or don't work with winter wheat, we're really trying to promote the use of cover crops. In this sense, the biggest cover crop that we generally use in Wisconsin would be cereal rye. If we can get farmers again to establish cereal rye in the fall in a northern climate such as Wisconsin, 10 days, 2 weeks earlier, we can get significant biomass production in the fall that helps hold the soil in place, helps recover the nutrients that that cover crop is holding for us, and being allowing us to be able to really capitalize on that amount of biomass that we're trying to do for carbon and nutrient loss programs. The other cool thing with this information is the number that we hear from our weed scientists is that you need 4,000 pounds of biomass in order to get a 50% reduction in weed biomass. So it effectively acts as another mode of action for controlling weeds. The key point is you go in, you plant early, you can plant an earlier maturity group bean, maximize your yield, you don't have any yield loss, get your winter wheat or cover crop established, and able to either maximize your winter wheat yield or get enough cover crop biomass established out there to be able to have another form of weed control to manage those troublesome weeds, such as the water hemp species that we see in the northern, corn growing region of the United States. Now we want to flip it around and really think about this on the flip side, because we're really trying to encourage farmers to, plant green as well. Now the question is, how does this whole maturity group planting date interaction role play on terminating cover crops? So how you would read this figure, again, it's a little bit of a challenging, I'll go through this. This is, again, our maturity group range from a 0.5 bean all the way to a 3.0 maturity group bean, okay? Here's our yield in bushels per acre of our soybean yield. And this axis down here shows us when we terminated that cover crop. So basically, the termination time 0 is we went in, we no-tilled our soybean into standing cover crop, cereal rye in this case, which would be time 0. We terminated it on that day. -15 would suggest or indicate that we terminated that cover crop 2 weeks prior to planting. +15 is we terminated that cover crop 2 weeks after we actually planted our soybeans. The cool interaction we see here is that we notice that up to from negative, or basically terminate 2 weeks before, up to planting date 0, which is when we plant green and terminate with glyphosate on that planting date, we see a fairly linear response to increasing maturity group. However, once that soybean starts growing into an environment where we have competition, and that competition in this sense would be that cover crop, we see a pretty exponential increase in what maturity group bean we should be planting in there to maximize yield. What does all that gobbledygook that I just say mean? What I mean by this is if you know you're going to be planting green and you want to terminate your cover crop late, by late I mean up to 2 weeks after planting, in order to maximize that biomass, to utilize that as either a carbon source or to utilize that as basically as a weed control mechanism, you need to increase the maturity group bean you plant in there in order to effectively increase your yield. So some really cool things that we're seeing with these interactions with planting dates and how we employ cover crops into the system. Now I want to revisit this whole boots on the ground validation thing to talk about a final project that was related to this north central region, and really kind of take all of this data that we took from the survey data and take it back to the farmers. So what this is known as, we were basically went back and used all the analyses from these 8,000 farm fields and these 600,000 acres of data, and we identified optimal recommended practices for specific TEDs, okay? And here's an example for Wisconsin where we see this interaction. And this, if you see here, we see this interaction for optimizing or recommending how farmers improve their soybean production practices. Every single state has early planting as a practice. Some have the addition of foliar fungicides, some have adding maturity group, some have adding or subtracting soybean seeding rates. But the key point we show here is that early planting, as we shown earlier, is a key driver, and then how that interacts with our other management practices to optimize yield. So here's an example of a reference field that we did, and I guess it's a drone shot from Nebraska just to kind of show. So what we did was we told farmers, you be you. You do what you normally do. You go in and plant your crop as normal. And that is what we see as these reference strips. Okay, this is what the farmer normally did on their farm. These improved strips, if you will, are what our modeling efforts based on the survey data told us that farmers should do on their land. These are improved treatments. And again, all of these employed an earlier planting date, which was earlier than what a farmer normally did on their reference strip. So here's an example of all the locations across the region that we did this in. You see Wisconsin, there was a lot in Iowa, Ohio, Michigan, Nebraska, Minnesota, some Illinois. So we had a good reference across the north central region from this data. Now, I'll interpret this data real quick. I'll explain these figures, and then we'll kind of talk about this. So how you would read this figure, this is basically yield from our reference treatment, okay, versus yield from our improved treatment, okay? So this reference treatment, as a reminder, is what farmers normally do on their farm. And this is from 2019, 2020, and 2021. This red line here is a one-to-one relationship. That means if our approved treatment was not better than the reference treatment, they were similar, they would fall on that line. If they were better, they would be above the red line. If our approved treatment was not as good as a reference, it would be below the red line. And as you can see, in each one of our states, okay, and we have roughly almost 150 comparisons of on-farm data, we see on average anywhere from a 3.2 bushel yield increase to a 5.5 bushel yield increase by implementing our improved treatments, which is primarily driven by early planting and the interactions that early planting had with either utilizing a fungicide, foliar fungicide, increasing or decreasing seeding rates, or other characteristics. So I think this is a really cool example how we can take this data, deliver it back to farmers, okay? Now the next question is, obviously we're making other management decisions and not just planting date. Planting date's free. It doesn't cost you any more to plant early or not. So the other question is, what value did that bring to the farmer, okay? What we see here from 2019, 2020, 2021, we saw anywhere from a $31 per acre increase in profit to a $53 per acre increase in profit by implementing our improved recommendations over what they were normally doing. So this is pretty cool data, really strong, tells us what's going on out there and the influence that these early planting dates are having on farming situations. All right, so in like the last 10 minutes we have here, I want to kind of talk about this other kind of what I think is a pretty cool project, trying to ask this question about what we should be doing in terms of what do we plant first, corn or soybean, okay? And what's really been driving this here is we got these questions. So they basically came to us agronomists and said, all right, you all are telling us to plant soybeans early, all right? Okay, we only have one planter. Or we can only run one planter based on labor shortages or just my time or the farm's time. So how do we prioritize what our planting order is? So one thing that we did is we were able to collect a bunch of data from across the United States and really kind of ask and answer these questions. And this information is all on my website, which is coolbean.info. I'm not going to get too much into specifics and get us lost in the weeds here, So if you want to understand the stats, feel free to read this. But I really want to do is kind of highlight a couple things. First of all, we were focusing in on both corn typical operations and soybean typical operations in terms of what our seeding rates were and what our nitrogen rates were on the corn side of things. We set some prices for corn and soybeans. Obviously, these are all off right now based on what commodity prices are sitting at. We set our soybean seed costs and our corn costs based on what farmers were telling us they were getting for seed costs for both of those different crops. And then we would try to pick a farm that was 5,000 acres. And you can do this for any size farm, okay? So one of the things we really wanted to do is kind of get an idea then over several different cropping systems, how well these different operations performed related to what's that yield loss associated with planting date and timing for both corn and soybean. So this is a field that we picked in Wisconsin. Again, that's my home state. And we just kind of dropped a pin, ran up an algorithm, a model to try and estimate what that response would be for our planting date. So the cool thing that we did with that then is I kind of zoomed through these is I want to focus just on this figure A right here. This would be a typical cropping system for both crops. What I mean by that is, you're optimized for both corn and soybean on this specific farm. And what this figure shows us, this is the corn and soybean revenue ratio. What I mean by that is this 1.00 relationship means that if you plant your corn and soybeans on that date, the revenue on a per acre basis would be 1-to-1. So it doesn't really matter. Okay, but you can't always plant all your crops on one day. What we found in this specific field, and we can do this for pretty much any field in the United States, is what is your planting order? So you remember back earlier we were talking about how our Science for Success team had worked with RMA to change our crop insurance date for replant coverage in Wisconsin to April 15th in southern part. That's where we ran the simulation and model. Well, the 110th day of the year is April 20th. If you see in this figure, prior to April 20th or this 110th day of the year, we prioritize getting soybean planted first, all right? So what I tell farmers, again, with similar soils and these type of environments, is if that soil is fit and you have, the capacity to go in and plant, you start planting on April 15th and you plant soybeans as fast and hard as you can until you hit that switch date, which is April 20th. At that moment, you flip, you switch over and you plant corn until you are done planting corn. And whatever acres of soybeans you have left, you finish on soybeans. So this is a really cool way for farmers to kind of get an idea of when do I plant my soybean first? How do I prioritize my planting order? So this is pretty cool. And any farmer can really kind of do this for their farmland. These are just some macro type of pictures. They really don't get into what that specific field level basis is. But for most of us here in these yellow orange states, basically it comes into right around, that last week of April is when, for the most part, we should start prioritizing corn planting. So roughly I tell farmers, if you're based on your specific location, you're supposed to be prioritizing corn planting April 20th, April 26th, and you can get in and have a few days that you could prioritize soybeans before you can plant corn. Get in there and hammer beans until you get to that flip date. And I think you will see a pretty significant yield advantage and pretty small amount of downside risk. As we've shown earlier, you can lose 2/3 of a stand of soybeans and only lose 5% maximum yield. So there's some cool things we can do here on a whole farm, whole state productivity in terms of maximizing our soybean yield. Okay. So I just like to show this figure here because we just ran a specific scenario on a farm. So this is our Arlington Ag Research Station. It's a farm. We know how their typical planting order is. And if we see right here, this is what our farm typically does. They have a specific planting order where they will plant this Arlington North field Okay, and this year, we'll just pick this year because there's going corn in that field because we're in a corn soybean rotation. They'll plant Arlington North first into corn. Then they'll switch to go to the Arlington South field. They'll plant soybean. And they'll go back to Arlington East field. They'll plant corn. And then Arlington West, they'll finish in soybeans. Okay, so this is typically how their order of operation is on the farm. And we see here that it provides somewhere in that $25,000 to $60,000 profit, depending on year, input costs. And there's obviously some variability associated with that. Now, one of the cool things we see, though, is by being able to go in and prioritize what that planting order should be based on starting April 30th planting, our modeling effort tells the farmers, plant Arlington South soybean field first, then go Arlington West soybean second, then go Arlington North corn, and then finish Arlington East corn finally. And what that does is by switching that planting priority, okay, you're still planting the same number of acres, you're just planting them in a different order, we're able to double, if not triple, our profitability on a per farm basis, which I think was pretty cool. I don't think any of this work has been done before. And I've been kind of talking about this data, and I think any farmer can sort this out themselves, work with a crop consultant, and understand which fields are the most productive, which ones can you get in first. If you can get in early before that flip date in your specific area, hammer soybeans, work on corn, finish on soybeans. So again, really trying to promote this early planting situation and increasing overall farm profitability. Now, obviously, a lot of this is driven here by planting date differences. So one of the challenges we notice here by changing our planting date to May 10th, we lose some of our profitability because we have that yield loss associated with delayed planting, but it also changes what our planting order should be. So again, this is not a static solution. This is a dynamic solution that farmers need to switch and change as they go through. But I think it's a really good exercise for any farmer to kind of try this on their farms and really see if on a per unit farm level basis, I think there's some really good areas we can explore by driving our early planting dates early, getting out of corn in some situations before that yield loss date flips, and be able to increase overall profitability at the whole farm scale. So I know I talked a lot of things about science for success today in early planting. I hope I've given farmers some things to think about and really to be able to maximize the profitability of these early planted situations. If you want to hear more from us, from our Science for Success team, please follow us on X at Soybean Science 1 for information related to everything that we put out. And if you have any final questions for me, all of my information can be found at coolbean.info. And you can follow me on X at @BadgerBean. Thank you for your time and enjoy your harvest and planting for 2025.